Okay, folks, this is part 4 of our video for section 8.1, Systems of Equations and Gaussian Elimination. This last example I'm going to do for you is, if I can grab my arrow here, this is going to be an inconsistent system. So if you flip back to the page 1 of your notes, you'll see that that means we're going to, at the end of this, we're going to prove that this system has no solution. And we're going to do that same procedure we did before. First thing I'm going to do is set up my table of coefficients and constants. So you can, I'm going to pause the video, you can check back here in a second. Okay, folks, here's my table of constants and coefficients. Remember, this column represents the coefficients on the x variables. This column represents the coefficients on the y variables. This column on coefficients on z. And here's all of our constants. Equation number 1, 2, and 3. Okay, we're going to go ahead and this one I mentioned it's inconsistent, which means it has no solution, and we're going to actually get there pretty quickly. One of the things that you have a choice when doing these problems is you can choose, do you want to get a 1 up in this first corner? You want to get 1 up there first, or you want to work towards getting the zeros here? I think to get a 1 in that upper left corner, I'd have to multiply everything in that row by 1/2, and then I'm going to be working with fractions for the rest of the problem. So because 2 is a factor of 10 and 2 is a factor of 4, I'm going to leave that 2 there for now, and I'm going to just work on the zeros down in this corner first. So the first couple things I can do here is I can multiply -5 times row 1 and add that to row 2 to get to get a 0 in this position. Similarly, for row 3, I can do -2 times row 1 plus row 3, and that's going to give me zeros in those first two positions for row 2 and 3. I'm going to go ahead and pause the video and do that for you right now. So after doing these two row operations, we end up with this for our table of coefficients and constants, and right away you ought to be a little concerned about this. Basically what we have here is two equations, -15y plus 4z equals -3, and -15y plus 4z equals +3. So right there we should be concerned that we have two equations that equal different things. So let's go ahead and I'm going to show you now how to get to the final answer here. But to do that, I'm going to try and get a 0 right here. Again, I'm trying to get zeros in this lower left-hand corner. To get a 0 here, I can do -1 times R2 plus R3. And I'm going to go ahead and rewrite row 1, 2, 3, -1, and 1. And row 2 will be unchanged. And then row 3. So we have the opposite of 0 plus 0, that's 0. The opposite of -15, which is 15 minus 15, gives me a 0. The opposite of 4 plus 4 gives me a 0. The opposite of -3 plus 3, which is 6. And there is our inconsistency problem. So right here in this bottom row we have the following statement. We have 0 equals 6. Folks, the last time I checked that was false, which is an indication that the system is inconsistent and we have no solution. And again, that one was pretty quick to get to that. But one thing I do want to mention is let's say that we were able to get a solution for this system. Remember, we're not done until we have a diagonal of 1s right along here. I'll go ahead and highlight that. Until we have that diagonal of 1s, we're not done. This case, we can stop early because we know it's inconsistent. But if I did have a consistent system, I would still have to go back and multiply this whole row by 1/2 and this whole row by -1/15 in order to get that 2 and that negative 15 to be a 1. Okay, folks, that's it for section 8.1. I hope you find these videos valuable. Best of luck to you in WebAssign.